This is a brief tutorial on identifying the types of chemical reactions. There are 5 basic types of chemical reactions we're going to discuss: the combustion reaction, the combination reaction, decomposition reaction, single replacement reaction, and double replacement reaction. So let's talk about the combustion reaction. Combustion reactions are rapid reactions that produce a flame. For example, if we burn some methane, where methane is CH4, we're talking about complete combustions here, so if we react them with oxygen, we're going to produce carbon dioxide and water. Notice that what we're going to burn is going to be a hydrocarbon, that is a carbon and hydrogen compound, or a compound of carbon, hydrogen, and oxygen for this to work. So if we consider carbon as the dark gray, hydrogen is white, oxygen is red, they will chemically react and you'll get 2 waters and 1 carbon dioxide. The combination reaction is a reaction where you have more than one reactant combining to form one and only one product. For example, carbon reacting with oxygen to form carbon dioxide. So there's 2 reactants and 1 product. So again, the same color scheme, and we bring those together to form 1 compound. There are a couple different types of combination reactions, one of which is a metal plus a nonmetal forming a salt. So, for example, magnesium and oxygen form magnesium oxide, where the formula of the salt product is the proper salt between the 2 elements on the reactant side. Aluminum and bromine forming aluminum bromide. Again, they've combined together to form one and only one product. Now, you could react hydrogen with a nonmetal to form a binary molecular compound between the 2. The hydrogen ones are fairly predictable, but other nonmetal combinations are not as predictable because many times there is more than one binary molecular compound that could be formed. For example, hydrogen and chlorine forms hydrogen chloride gas. Hydrogen and oxygen reacting to form water. Decomposition reactions are reactions where one reactant is going to break apart to form 2 or more products. And in many cases this occurs when the substance is heated. It could happen when electric currents run across the substance also. Like for example, water, if you run an electric current across it, you will form hydrogen and oxygen gas. So it is the reverse of the combination reaction. And sometimes these are more difficult to predict the products of, but there are a few predictable ones. For example, if we take our 2 water molecules here and we split them apart, they will react to form oxygen gas and hydrogen gas. Carbonates and bicarbonates will decompose when heated. The metal carbonate or bicarbonate will react to form a metal oxide and carbon dioxide gas. For example, calcium carbonate, solid, you heat it, you form calcium oxide, which is the metal oxide for calcium, and CO2 gas. Chlorates and perchlorates will decompose as well when heated. The metal chlorate or perchlorate will decompose to form a chloride salt of the metal and oxygen gas. 2 potassium chlorates will decompose when heated to form 2 potassium chlorides and 3 oxygen gas molecules. And those are fairly predictable. Other ones are not as predictable. Your single replacement reactions occur when an element displaces another element within a compound. and such it forms a new substance. The zinc reacts with HCl in this case, where the zinc is going to displace the hydrogen. And so now you got zinc with chlorine, so it's replaced the hydrogen, and you've got hydrogen gas by itself. So one element has displaced another, and now you see the opposite element combined with the nonmetal, and you've got hydrogen gas. Now the lighter gray there is zinc, the green is chlorine, white is still hydrogen. And they will react. The hydrogens will come together in hydrogen gas, which is given. There are a number of different cases where we have single replacement reactions. Group 1A metals react quite vigorously with water to produce hydrogen gas and a hydroxide of the metal that was added. For example, for sodium and potassium, we get sodium reacting with water to produce sodium hydroxide, so there's your metal hydroxide, and hydrogen gas. You get a very similar reaction for potassium reacting with water to produce potassium hydroxide and hydrogen gas. And all the elements in that particular column will do that. Metal can react with non-oxidizing acids, for example hydrochloric acid, to liberate hydrogen as well. Remember our zinc reacting with hydrochloric acid to produce hydrogen gas and zinc chloride. That would be a good example of that. But only certain metals will do that, as we'll find. Metals can displace other metals in the salt, but the trick is the substance that is doing the displacing needs to be more active than the element within the salt. So in this case, copper will displace the silver out of the salt to produce silver metal and cupric nitrate. The opposite reaction does not occur. And you see that you get a big fat no reaction. Nonmetals can also replace other nonmetals. Bromine reacts with sodium iodide, so the bromine is going to replace the nonmetal in this case. This is something called the activity series. Things higher up on the activity series are more active. Things at the bottom are less active. So something higher up on the activity series will displace something that is lower and farther down. The substances in blue are active enough to displace hydrogen gas from water, steam, and acid. The elements in the green area will displace hydrogen gas from steam, or really, really hot water, and acid. The yellow will displace hydrogen gas from acid only. Things down there in the orange will not displace any hydrogen gas, and those are the least active of all. For non-metal displacements, for example halogens, the fluorine is most active, the iodine is least active, so anything higher up on that column of halogens in group 7A will displace anything lower down on that column. So fluorine will displace chlorine, chlorine will displace bromine, bromine will displace iodine. Double replacement reactions. Essentially they're just swapping partners. The cation will swap which anion it's associated with. For example, if you react zinc sulfide and HCl, the zinc is going to go with the chloride, the hydrogen is going to go with the sulfide, and so we get zinc chloride and hydrogen sulfide gas. So in this case, the yellow is the sulfur, and when you get them together, you get the zinc with the chloride. Again, those will be ions in solution. The hydrogen sulfide will be a gas, which will be evolved from the reaction solution. There are a number of different types of reactions, but they'll all have one thing in common. There has to be a driving force to cause the reaction to occur, and you need an insoluble solid that is formed and precipitates from the reaction. You'll need a weak or non-electrolyte formed. For example, a gas like carbon dioxide could be formed. You can form a covalent compound like water, or a weak electrolyte like ammonia or acetic acid or something like that. There are several different types. Acid-base neutralization. where an acid, like hydrochloric acid, will react with a base, like a metal hydroxide, like sodium hydroxide. And the sodium's going to go with the chloride, the hydrogen's going to go with the hydroxide. So we get sodium chloride and water. And of course you'll balance each of these. You can get precipitation. The barium is going to go with the nitrate, the silver is going to go with the chloride, but it turns out silver chloride is not water soluble. And so it will precipitate from the reaction. Barium nitrate will stay in solution. Formation of a gas, like the one I showed you on the previous slide. When you form the hydrogen sulfide, that's formed and bubbles out of the solution. Now, sometimes you can form a gas indirectly, and that's because one of the products from the double replacement is unstable and it decomposes. There are three basic types of that we'll discuss. Carbonic acid, if it's formed, usually from a carbonate reacting with an acid. The H2CO3 that you would predict that forms decomposes to form carbon dioxide and water. Very similarly, if you react an acid with a sulfite, you form H2SO3, which would decompose to form SO2 and H2O. Now, ammonium hydroxide is often formed from reacting a hydroxide compound with a compound containing ammonium ion, and that would form ammonium hydroxide, which will decompose to form ammonia and water. So let's look at each example. If you react an acid with a carbonate or bicarbonate, like sodium carbonate with HCl, the hydrogen's going to go with the carbonate, the sodium's going to go with the chloride. You predict that you would get the sodium chloride and the carbonic acid, but we're going to split that carbonic acid up into CO2 and H2O. Very similarly, an acid like HCl with a sulfite or bisulfite, you'd swap the ions and get the sodium chloride, but you'd predict you'd get that sulfurous acid, but we're going to split that up to form SO2 and H2O. You got a hydroxide salt with the ammonium ion. Again, you're going to get sodium chloride from the sodium hydroxide, but with the ammonium is going to go with the hydroxide, and you would predict you'd get ammonium hydroxide, but you're going to get ammonia and water. So those are some cases where you get a little indirect formation of gas and you don't quite get the double displacement products you think you would. So this has been a brief tutorial on chemical reactions.